So if I take an example, oxidation. So if we have sodium and chlorine reacts together and it forms sodium chloride. So is it a redox reaction? So we will see how it is a redox reaction. So as sodium is a metal, and you all know about this and you must know about this, chlorine is a non-metal. Metal has tendency to lose electrons and non-metals have tendency to gain electrons. So when one metal reacts with non-metal, then there is a redox reaction happens. So if I show sodium loses one electron to form positive ion and chlorine gain one electron to form chloride ion. So this is loss of electron and here it is gain of electron. You can show this like here, Na losing one electron to form positive ion. So in some books it is given like this. So you can write this way or this way. So loss of electron and gain of electron. As sodium is a reactant which is losing electron. So sodium is oxidized. Sodium is oxidized. Whereas chlorine has gained one electron, so it is reduced. But as you can see, there are two chlorine atoms, so we need two. So there will be two chloride ions and there will be gain of two electrons. So we need to balance them every time. So as it is one sodium atom is losing one electron, so two sodium atoms will lose two electrons because chlorine needs two electrons to form chloride ion. So please remember these number of electrons lost or gained should always be equal. So this is the reaction. So loss of electron is oxidation and gain of electron is reduction. And if I write the overall reaction, so it will be like 2Na plus Cl2 gives Na plus Cl minus. So that's how the oxidation and reduction reactions are taking place in this example. Now I will move to the next slide. So here in this example, again I am taking magnesium plus sulfur, it gives magnesium sulfide. So here if you know periodic table, you will see magnesium is a metal whereas sulfur is a non-metal. So magnesium has tendency to lose two electrons to it. So you know that this one 282. So by losing two electrons, it will attain stable gas configuration, that is 28. So it's a stable configuration, whereas sulfur is 286. So to attain stable gas configuration, it has to gain two electrons to form sulfide ions. So here it is loss of electron, two electrons, and here it is gain of electrons. So as you know now that loss of electron is an oxidation and gain of electron is reduction. Or in other words, we say magnesium is oxidized and sulfur is reduced. So again, it is an example of redox reaction. And if I write it, overall reaction, it is MgS. So that's how we write the oxidation, reduction reactions, and we explain in terms of electronic concept of oxidation and reduction. Next is, hello everyone. Today we are going to learn about redox reactions. If you see redox reactions and the name, it is made up of two words. Reduction and oxidation. Reduction and oxidation. So there are some chemical reactions in which reduction and oxidation takes place simultaneously. So redox reactions are always the reactions in which both reduction and oxidation takes place simultaneously. If reduction is happening in the reaction, so there must be oxidation. If oxidation is happening, there must be reduction. So they are complementary reactions. So those reactions are called redox reactions. Now we will learn about the electronic concept of oxidation and reduction reaction. So electronic concept of oxidation and reduction. So as I said, oxidation and reduction reactions are chemical reactions where electrons are involved. So we are going to learn about electronic concept of oxidation and reduction. So what is oxidation? So first we will do oxidation. So in a chemical reaction, when there is loss of an electron there is a loss of electron by a reactant, then it is called oxidation. So loss of electrons by a reactant. And reduction is gain of electrons by a reactant. So one reactant is giving electron and the other reactant is taking or gaining electrons. So that's why I said they are taking place simultaneously. Now I'll take one example here. Now there are two new terms here we are going to introduce. First is oxidizing agent and reducing agent. So OA and RA. So if I take this example again, sodium, then chlorine, and it forms sodium chloride. So as I said, sodium is oxidized by losing electron and chlorine is reduced by gaining electron. So oxidation, reduction. So there is an oxidation of sodium and there is reduction of chlorine. So sodium is oxidized to form sodium ion. Chlorine is reduced to form chloride ion. So oxidation, loss of electrons, and reduction is gain of electrons. So sodium is oxidized. chlorine is reduced. Now, as I said, we are going to introduce new terms, oxidizing agent and reducing agents. So which one is oxidizing agent here is the reactant which is helping, oxidizing agent is the reactant which is helping in oxidation of sodium. So which is helping in oxidation of sodium? Chlorine. How it is helping? Because the electrons lost by sodium is gained by chlorine. So chlorine is helping sodium to lose electron by gaining those electrons. So whichever substance is reduced is an oxidizing agent, and whichever substance is oxidized is a reducing agent. So oxidizing agent is the substance which helps in oxidation of other reactant, and reducing agent is the substance which is helping in reduction of other reactant. So sodium is helping in reduction of chlorine, so it's a reducing agent. Chlorine is helping in oxidation of sodium by gaining electron. That's why chlorine is your oxidizing agent. So that's how we find out the oxidizing agent and reducing agent. So I will take one more example. This example which we have taken previously. So MgS. So as I said, magnesium is oxidized. So oxidation of magnesium, and sulfur is reduced. So reduction. So we write magnesium is oxidized and sulfur is reduced. So there is loss of electron from magnesium, and there is gain of electron by sulfur. Okay. So as magnesium is helping sulfur to gain electron by losing electron, right? So magnesium is your reducing agent. And reduced, sulfur is reduced means it helps in oxidation of magnesium by gaining electrons. So it's a oxidizing agent. So that's how we find out the oxidizing agent and reducing agent.